Hello, welcome to the January 2023 Edexcel IGCSE paper 2H walkthrough. Question number 1 is a dividing fractions questions. Be careful, it's a show that question, so don't skip out any steps, otherwise you will lose marks. I've turned them into top-heavy fractions. I've flipped the fraction that I'm dividing by. I've cancelled, showing my cancelling clearly, and that comes out to 16/7, which is 2 2/7. No room for ambiguity there, no big steps. Make sure you get all the marks for question 2. 90 kilometers per hour times by 1,000 to turn that into meters per hour, and then divide by 3,600 to work out the number of meters per second. That's equal 60 times 60 comes out as 25. For question 3, the Venn diagrams, well, the intersection is 12, 16 and 20, so I can write those in. I can fill in the remaining even numbers and work out the rest. It's a fairly straightforward question with a little bit of logic applied. Like so. Question number 4. It gives us A to D and B to C in terms of x, and we know this is a rectangle, so those two lengths must be the same. Allows me to form an equation we can solve to find what x is. Bring the 3x onto the left, add the 1 to both sides, divide by 2. And if we plug 4.2 into either expression, we'll get 20 out as the length A to D or B to C. And therefore we can work out the perimeter of the shape, which comes out as 88 centimeters. Lower bound is 2.745, upper bound is 2.755. If we do a little bit of rounding, we'll round to one significant figure in all the cases, so 80 times 60 over 2 squared, or if you prefer 8,400 over 4 is 1,200, which is not close to 13,332, etc., etc. So there must be a mistake somewhere. This is not a sensible answer. Okay, question 6 about midpoints. So halfway between 6 and 17 for the x-coordinates will allow us to work out k. So 6 plus 17 over 2 is 11.5. And then for j, well, halfway between them is 15. So 4 plus j over 2 is equal to 15 gives us a little equation we can solve. It gives us j to be 26. Question 7, a fairly standard set of simultaneous equations. A few ways of doing it, or many of them are legitimate. You must show clear algebraic working. A correct answer will not score any marks without the method there. I've taken the second equation and multiplied it by 4. Added the two equations together. We get 13.5 equals 15.6. Divide both sides by 13, x is 1.2. Substitute that into the second equation. You could, of course, substitute it into the first if you want. Anyway, y comes out as -2. Question number 8 wants to know the difference between the two banks. So for bank G, we've got 5,000 times by 1.016 squared. That's a compounding interest. And we subtract 5,000 times 1.029 gives 16.28 Swiss francs. Anything to the power of 0 is 1. And then 2 cubed is 27. 80 squared cubed is a to the 6 and then b to the 12. Just times the powers there. Factorising fully, the highest common factor is 7x squared y squared. That is the only correct answer for a full factorisation. And then y equals 4 minus 2x. If you did minus 2x plus 4, that's absolutely fine. For question 10, we've got the isosceles triangle. If I subtract 24 from 54, it gives me the sum of the final two lengths. So I can halve that, which comes out as 15. So each of those two side lengths is 15. Doing a bit of Pythagoras on either side of the triangle at 15, subtract, and then it's half of 24, which is 12 squared. Square root that and you get 9, so the perpendicular height of this triangle is 9, and finally a half times base times perpendicular height will give us the area, which is 108 centimeters squared. Question number 11, it's graph recognition. Minus 2 over x is a negative reciprocal, so it's B. And then we've got a negative parabola, which is A, and then a negative cubic, which is F. You just got to know your graphs and what they look like. If you do that, that question's straightforward, or you can just plot them and look. That would work as well. Question 12, if we draw a line at 30 and then track it down, we'll get a median of 44. Anything between 43.5 and 44.5 is acceptable. For longer than 55, I'll draw a line up at 55, measure it across, comes out as 49. So if I do 60, take away 49, we get the 11. If you got 12 for that, that would be absolutely fine as well. For part C, you can just read off each point and work out how much it's gone up by to work out what goes in each category. It's very straightforward to do. So 7, 10, 15, 15, 5. Okay, question 13. Multiple correct starts. I'm going to create a common denominator. Multiply the first fraction, the top and bottom, by 5, and for the second one, the top and bottom by 4. Common denominator of 20. And then I'm going to carry out the subtraction. Just be careful with your minuses here. You've got 5x, subtract negative 4x will come out as 9x. 15, subtract 28 is negative 13. Multiply both sides by 20. Add your 13 and divide by 9. And you'll get x equals 11. You must show clear algebraic working. 11 on its own doesn't score you anything. Question 14, angle DCB is going to be 140 degrees. For the reason, you must give certain keywords. Here, opposite angles on a cyclic quadrilateral sum to 180 degrees covers all of them and more. So opposite angles, cyclic quadrilateral, sum to 180 degrees for that one. For ADO, a little bit trickier, double the angle at the centre is double the angle at the edge, so DOB is 80, and then we can work out the angles in that isosceles triangle. That ODB will be 50, ADB will be 66 because of alternate angles, it's alternate to angle ABF. And the difference between 66 and 50 is 16 degrees, which gives me the angle ADO. Question 15, they like to give questions with sets of 11 numbers, because 11 is quite a nice number. We've got a median right in the middle there, is the 26, and then we can split up the left-hand side into the two, circling the 4 and the 36, gives us some nice quartiles. Difference between the lower quartile and the upper quartile is the interquartile range, so 34 take away 4 is 30, so 30 is the interquartile range. It does want us to do a comparison, so we will compare the interquartile range of the two teams. 30 is of course less than 42. An interquartile range measures spread of data, so the spread of runs scored by team A is less than the spread of runs scored by team B. Something along those lines, mentioning the spread for one being less than the spread for the other is sufficient. Question 16 is a standard recurring decimal to fraction question. I like to put the recurring part up against the decimal point, so the first thing I'm going to do is multiply by 10. We've got two recurring numbers, so I'm going to multiply both sides by 100 there, so giving us 1000x is 438.38 recurring. And then if we subtract 10x from 1000x, we get 990, and that will be equal to 434, because the recurring parts will cancel. Divide by 990 and simplify to get 217 over 495. Question 17 is a surds question. The square root of 49m you can write as the square root of 49 times the square root of m, so that's just 7 root m. Similarly, the square root of 9m becomes the square root of 9 times the square root of m, which is 3 root m. Simplify that down to 12 root m, and you can see that k must be 12. For B, it's rationalizing the denominator. We multiply by the conjugate pair, so we've got a 1 minus root 2 on the denominator, so I'm going to multiply by 1 plus root 2 over 1 plus root 2, which is a fraction equivalent to 1, so it doesn't change the value of our answer, just the way it looks. Doing a double bracket expansion at the top, just make sure you're doing it carefully. Because it's a show that question, and it even says show each stage of your working clearly. For the root 18, I am clearly showing that root 18 is root 9 times root 2, and therefore that simplifies to 3 root 2. I cannot jump from root 18 to 3 root 2 because your calculator will do that and you won't have shown it carefully. The rest of it is fairly straightforward. You're collecting your root 2's and your non-root 2's, and then do a last minute cancellation with negatives, and we get 1 minus 2 root 2 for a fully correct answer. You can give A and B if you wish. Question 18, histograms. We're looking at frequency density, so I'm dividing the frequency by the class width. So the first one is 12 divided by 2, and 7 divided by 1, 15 divided by 3. For each of those class widths, I'm just working out the difference between the start and the end point of the class. And we'll plot some bars that have the correct height in terms of their frequency density, and also span the width of the class itself. And you should have something that looks exactly like that. Do use a pencil and a ruler for that one. Splitting it to the more than 7 kilograms, well, there are 8 in the first lot just there, that's 2 times 4, and then we already know there are 9 in the final class width, so that gives us a total of 17 out of the 55, which is the sum of the frequencies. Probability there, 17 out of 55. So we have 2 similar vases. It tells us that the surface area of vase B is 25/64ths of the surface area of vase A. So this question's clearly dealing with scale factors. It gives us scale factor of areas. From that we can work it out as being 1 to 25/64ths. To make this question easier, I'm actually going to rewrite that ratio as 64 to 25. Essentially multiply both sides of the ratio by 64. It allows me to carry out some nice square roots to get the scale factor of lengths. Of course, the scale factor of lengths is the square root of the scale factor of areas. The square root of 64 is 8, and the square root of 25 is 5, so the scale factor of lengths is 8 to 5. To find the scale factor of volumes, I'll cube those. 8 cubed is 512, 5 cubed is 125. We know the difference between their volumes is 541.8. So if we work out what that counts as in terms of parts of this ratio, we can find sort of the value of one part and then work out the new volume. So the difference between 512 and 125 is 387. So 387 parts is 541.8. So if we divide 541.8 by 387 and then times that by 125, that's the number of parts in vase B, it will give us the volume of vase B, which is 175. Question 20, nonlinear simultaneous equations. They've set up a substitution for us straight away there. We don't need to do any work on this one. Substituting y for 7 minus 2x. Plug that into the second equation. Expanding out 7 minus 2x, we'll get 49 minus 28x plus 4x squared equal to 34. At this point we're dealing with a quadratic. It's a 3-term quadratic. I'll bring everything onto the left. 5x squared minus 28x plus 15 equals 0. And that factorizes nicely to 5x minus 3x minus 5. If you chose to do the quadratic equations formula or even completing the square, although that's probably not a sensible way of doing it, that is absolutely fine as legitimate methods, but you do need to show your method here. It does say in the question, show clear algebraic working, and there are your answers. They come as pairs. Question 21, volume of a sphere and the surface area of a sphere. But the surface area of a sphere is 4 pi r squared, so we can equate that to 49 pi. The pi's will cancel, divide by 4 and square root. You'll get r is 7 over 2 or 3.5. And to find the volume, we'll substitute that radius into 4/3 pi r cubed. So 4/3 times pi times 3.5 cubed, or 7 over 2 cubed, comes out as 343 over 6 lots of pi. Or if you prefer, and the question does prefer because it wants it to the nearest integer, that will be 180 centimeters cubed. Question 22 is a quadratic inequality. So we will bring the 35 onto the left-hand side and factorize that down. So 6x minus 5 and x plus 7. Some people at this point will start to test values. If you've drawn a graph and you're identifying regions of the graph between critical values, that's absolutely fine. Number of ways of doing that. The important thing is that minus 7 and 5/6 are when it's equal to 0, and so the range of values of x will be in between those two because it's less than 0 on a smiley face quadratic. All right, question 23, a bit of a trickier one. First thing I do is going to draw some lines in on the graph to help us there. We've got the line from A to M and from A to J. I've called M the midpoint of GH, and we can clearly see the theta that we're going to measure there from MAJ. I'll mark that in there. That's the angle we're after. J to I to F is 30 degrees, as also labelled on there. A to M, we'll do a bit of Pythagoras on the flat triangle. So A to M is going to be the square root of 12 squared plus x squared, because x is half the distance from A to B. For M to J, we can add x to where the line is across the back up to J using a bit of SOHCAHTOA. So it's going to be x plus and then 8 sine 30 will give you the whole distance from M to J. And also we know that there's a length x in there, so we can work out that cos 30 will be x over 8. Therefore timesing by 8 we'll get x equals 8 cos 30. Cos 30 is root 3 over 2. It's one of those standard ones. You can do that on your calculator if you wish. And I've simplified x to 4 root 3, although you could have left x as 8 cos 30, or even just calculated it as a decimal and use the answer button on your calculator. That's absolutely fine. So to find theta, we now have J to M and A to M. So we're going to say that tan theta is 4 root 3 plus 4 all over the square root of 12 squared plus 4 root 3 all squared. And then we just do inverse tan of all that. I've done a bit of simplifying here, but that wasn't strictly necessary. You could just put it all in one go. And the angle comes out as 38.3 degrees. Question 24, there's a few ways of doing this one. Draw it, look at the sizes. It goes from -2.5 to 3, so it's got an amplitude of 3, and everything's been shifted up by half a square, so b is 0.5. Any number of ways of working that one out. Try it, draw it, whatever works for you. Question number 25, this is an inverse functions question. It's one of the trickier ones because we're dealing with a quadratic. If you have a quadratic equation, the best way to find the inverse function of it is by completing the square and then reverse engineering it. I swap the x's and y's around. Some people like doing it that way. It's not necessary. If you haven't, that's absolutely fine. Completing the square, factorise out the 3, half of -4 is -2. Expand it back out again, and we get x is equal to 3 lots of y minus 2 squared minus 5. That's now something that we can start to reverse engineer. So I'm going to add 5 to both sides, and then divide both sides by 3. And then this is where many is going to catch many people out here. We're going to take the square root of both sides, but we want the negative square root. And the reason being is that in the top line, it tells me that x is less than or equal to 2. So it's the negative square root that we want there. Add the 2 to both sides, we'll get 2 minus root x plus 5 over 3, and that's the inverse function for question 25. Question 26, playing about with indices and bases. I've put in a couple of extra lines. I'm going to split the 10 up into 2 times 5 first. I'm going to split the 20 up into 2 squared times 5. You can think of that as some sort of prime factor decomposition. I've also expanded out the powers in the numerator just for ease of playing about with them. 2 times 5 to the 4n splits into 2 to the 4n times by 5 to the 4n is the first thing that I'm going to do there. And I'll leave the other 2 and 5 in the numerator alone for now, and split the denominator up into 2 to the 4 times 5 squared. Now at this point, if you look carefully, all of the 5's will cancel. You could imagine doing 5 to the 4n times by 5 to the 2 minus 4n. The 4n's will cancel, and you'll get 5 squared divided by 5 squared. So that will cancel. So we're just looking at the 2's now. We've got 2 to the 3n squared. Then we've got a minus 15n plus 4n gives me the minus 11n. And the 4 on the denominator becomes a minus 4 as the power. That's equal to 1. Anything to the power of 0 is 1. So therefore the power must be equal to 0. It gives me a quadratic in terms of n that I can factorize. And from the factorized version, I can calculate the 2 values of n as -1/3 and 4. Congratulations if you managed to puzzle that one out. Bye.